Hello guys, today's topic is relative formula mass. Key learning points: define relative formula mass, calculate the relative formula mass for a compound, calculate the percentage mass of an element in a compound. What is relative atomic mass? Mind this that this topic has already been covered in the previous lecture. You can go and check in the playlist of atomic structure. We have kept this slide in this lecture to have a recall because we might be needing it. So it is the mean relative mass of the atoms of different isotopes in an element. It is the number of times heavier an atom is compared to 1/12 of a carbon-12 atom. It is also equal to the number of protons and neutrons in an atom. The relative atomic mass of oxygen can be found next to the chemical symbol on the periodic table. It is 16. You can see in the example of oxygen, 16 is the mass number or relative atomic mass of oxygen. There's a question for you. Tell the relative atomic masses of the following elements: sodium, lithium, and helium. On the left hand side, the elements and symbols are given. You can check that, or if you want to take the help of periodic table, you can do that as well. Pause the video, think of an answer, and then check your answer. For sodium, it is 22.99. You can see from here, and also you can write it as 23 as well, a whole number. For lithium, it is 6.941, or you can write as 7 as well. For helium, it is 4.003, or you can write 4 as well. Either this or this, both will be correct. What is relative formula mass? The relative formula mass is the sum of the relative atomic masses of all the atoms in a chemical formula. It is represented by Mr. For example, hydrogen chloride, it has hydrogen in it and chlorine atom in it. The relative formula mass of hydrogen chloride or hydrochloric acid is atomic mass of hydrogen plus atomic mass of chlorine. The atomic mass of hydrogen is 1.008 and atomic mass for chlorine is 35.45. Addition of these two will give us the relative formula mass of hydrogen chloride, that is 36.458. There's a question for you now. Calculate the relative formula mass for water. Water has the molecular formula as H2O. Below are the given elements, symbol, atomic number, and weights. Pause the video, calculate, and then check your answer. If your answer came out to be 18.016, you are correct. If not, I'll explain it to you. In water molecule, there are 2 hydrogen atoms and 1 oxygen atom. The calculation will proceed as 2 atoms of hydrogen into atomic mass of hydrogen. Atomic mass of hydrogen is 1.008 and there are 2 atoms of it. Addition, one atom of oxygen into mass of oxygen atom, that is 16. So the total comes out to be 18.016. There's another question for you. What is the correct method to calculate MR, that is relative formula mass of CO2, that is carbon dioxide, The molecular formula has been given to you. You can use the periodic table to calculate it if you want. Pause the video, answer it, and then check. If your answer came out to be 44 and second one is the correct, then you are absolutely correct. If not, I'll let you know. Carbon atom is 1, oxygen atoms are 2. So carbon has atomic mass of 12 plus 2 oxygen atoms. 1 oxygen atom has a mass of 16. This gives you 44 and this is the correct representation. Another question for you. Calculate the relative formula mass of ammonia. Ammonia has a molecular formula of NH3. Pause the video, calculate, and then check your answer. If your answer came out to be 17.034, you are correct. I have given the explanation in there that there is 1 atom of nitrogen and 3 atoms of hydrogen. 1 atom of nitrogen has the weight 14.01. 3 atoms of hydrogen, each hydrogen atom has weight of 1.008, and this is how your answer came to be. Calculation of MR from displayed formula. The example here given is of ethene. There are 2 carbon atoms. 1, 2. Count up the carbon atoms. Then count up the hydrogen atom. 1, 2, 3, 4. There are 4 hydrogen atoms. So carbon 2, hydrogen 4. This is how we wrote the molecular formula by looking at the displayed formula. We know mass of hydrogen. You can either use 1 or 1.008, whatever in the question it will be given. For carbon, it is 12.01, or you can write 12 as well. So the relative formula mass of ethene is mass of carbon, that is 12.01, into number of carbon atoms, that is 2, plus mass of hydrogen atom, that is 1.008, into number of hydrogen atoms, that is 4. It comes out to be 28.052. You can also write it as 12 into 2 plus 1 into 4. That will also be correct. If nothing is given in the question, any way you want to do it. If it is given to 1 decimal place, then do it accordingly. If it is given just like this, that symbols are given, you just have to do it like this. Next question for you is, which represents C4H10? Pause the video, think, calculate, and then check your answer. If your answer came out to be C, it's correct. How? We'll see. Which represents C4. It means it should have 4 carbon atoms and 10 hydrogen atoms. For A, let us check. 1 carbon, 2 carbon, 3 carbon, 4 carbon, and 5 carbon. So it is wrong because we need 4 carbon. B, 1 carbon, 2 carbon, 3 carbon, 4 carbon. So carbon atoms are fulfilled. For hydrogen, let's check. 1 hydrogen, 2 hydrogen, 3 hydrogen, 4 hydrogen, 5, 6, 7, 8. Hydrogen is 8 and carbon are 4. We need hydrogen as 10. Let's check the C1. 1, 2, 3, 4. 4 carbons and 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. So 10 hydrogen, which matches with the question, hence C is the answer. Now calculate the relative formula mass for C4H10. The masses, atomic number and the element are given to you. Pause the video, calculate and then check your answer. If your answer came out to be 58.12, you are correct. You can read the explanation and it will be very clear to you. Next question. Calculate the relative formula mass of glucose. Everything has been provided to you. Pause the video, calculate the answer and then check it. If your answer came out to be 180.156, well done. You have understood the concept. Equation mass. In a balanced chemical equation, mass is conserved. This sign represents summation. So summation of Mr reactants, it is equal to summation of Mr products. What are reactants and products? Reactants are the starting materials and products are the end results. For example, hydrogen when combines with chlorine, it gives hydrogen chloride. In here, hydrogen and chlorine are the starting materials, so they are reactants, and hydrogen chloride, which is formed, is the end result, is the product. To calculate Mr or relative formula mass for reactants, we can do it as two atoms of hydrogen, relative formula mass for hydrogen, plus two atoms of chlorine into relative relative atomic mass of chlorine. You can find it in here. This comes out to be 72.916. Now Mr for product, it is equal to 2 molecules of HCl. 2 into hydrogen has mass of 1.008 plus chlorine has mass of 35.45, which comes out to be 72.196. Both of them are same, hence mass is conserved. Question for you. If the Mr, that is the relative formula mass of the reactants, is 60, what would be the Mr of the products be? 60, 120 or 30? Pause the video, think and then check your answer. If your answer came out to be 60, then you are correct because the mass is conserved. Percentage by mass in a compound. It can be calculated if you know first the mass of the element in the compound, second the Mr of a compound. Mass of an element in a compound can be checked from periodic table. And then Mr of a compound, it can be easily calculated if you know the relative atomic mass, which can be checked from periodic table. Now, percentage of element in a compound, it is equal to mass of element in a compound into 100 upon formula mass. Example, find the percentage of nitrogen in ammonia. Ammonia has one nitrogen atom and three hydrogen atom. This we came to know from periodic table. Okay, mass of nitrogen is 14. So mass of ammonia will be, for nitrogen, the mass is 14 plus 3 because there are 3 hydrogen atoms into 1 because 1 is the mass of hydrogen. So the mass of ammonia comes out to be 17. Now, percentage of nitrogen in ammonia is 14 divided by 17 into 100. It comes out to be 82.35. That means there is 82.34% of nitrogen in ammonia. Rest of it is hydrogen. There's a question for you now. Calculate the percentage of hydrogen in methane. Pause the video, calculate the answer, and then check. If your answer came out to be 25.13, you are correct. If not, go through the calculation. Everything is made really clear. Go to the previous slide, check the formula, come back again, tally it, and then try to solve again. So this was all about relative formula mass. Check out YouTube shorts or Instagram handle for practice questions.